BJT. Here we have a BJT. You see that in the BJT we have collector, base, and the emitter, and between the base and the emitter we have the VBE voltage, and also there's an R pi resistor as well. Okay, and IB current pass through the base, and collector has IC current, and that one also can be expressed as GM VBE. If you want to know how to derive this expression, I did it in my previous video. I did it from scratch, so you can watch that. And then we have emitter current IE, and this is emitter. Okay, if you put it in the hybrid pi model, this circuit is going to look like this. We are going to have a shape like a pi that is flipped downward. So in that the top of that we are going to have a base, and then here we have a collector, and in the bottom we have emitter. Okay, and this one is the base, this one is the collector, this one is the emitter, and from base to emitter we have this voltage and this resistance, so we include that. So here we have a resistance right here, that one is R pi, and let's put it in the other side. Okay, this is R pi, and we have a voltage right here, and that one is VBE between base and the emitter. And if you notice the collector and the emitter, there's a current flow IC. Okay, this IC is coming from collector to emitter, and the current coming through this is IC, and that exact same current can be expressed as GMVBE. So I put it as a current source right here, and express this one as GMVBE. Okay, and all of them goes to the emitter, and the current through the emitter is current that goes through the emitter is IE. Okay, so this is the hybrid pi model diagram. Hybrid pi model. Okay, it's called hybrid pi model because this one look like a pi, almost like a pi shape flipped downward. So that's why this one is called hybrid pi model. And also this one is, this circuit we have right here is called voltage control current source, because the current source has a voltage term with it. Voltage controlled current source. Okay, and this current source can also expressed in terms of current as well, because there's a relationship between VB and IB current. Let's look at that. So GM VBE in terms of IB current, there's a relationship between VB and the IB current, that is VB is equal to IB times R phi. I also derived this equation in my last video. I did it from scratch, you can watch the video. And VB is equal to R phi times IB. Not, let me try it better. So IB times R phi. Okay, so this is equal to GM IB times R phi, and here okay, let me write R phi this way because there's another thing we can write in terms of R phi times IB, and there's a relationship between R phi and GM, that is R phi is equal to beta over GM. Okay, so we can use that one over here. If you use that, then GM times beta over GM cancel, so we will end up getting just beta times IB. Okay, so what we can do right now, so now we have derived an expression for GMVB in terms of IB, And in this hybrid pi model circuit, we can simply replace that one with this one as well. The only difference we are going to make here, the only difference is we change this one into beta IB. It's the same thing, and this current is IC right here. Okay, the same thing, but for this one we are going to call a different name. This is also hybrid pi model. But the name for this one is current dependent current source, because the current source is expressed in terms of a current. So we call this one as current dependent current source. Okay, and that is it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.